What if your CI/CD pipeline had an AI engineering team? Not one giant AI team, a team. One agent checks Terraform, one hunts for security vulnerabilities, one analyzes infrastructure cost, and one monitors the health of the pipeline. And when a pull request opens, they all start working in parallel. Sounds great, but now we have a problem. Who manages the team? Who decides which agents should run? Who waits for everyone to finish? And more importantly, what happens when something fails? That's where two very different technologies come together. One decides what should happen, the other makes sure it happens reliably. Hello everyone, welcome back to my channel, The Techie Chef. Today we are going to build this multi-agent DevSecOps AI system from scratch and see how LangGraph and Temporal work together to turn a collection of AI agents into a production-grade system. Let's build it. It starts the same way every PR does. A developer pushes a change to a GitHub repo, nothing exotic yet. That change becomes a pull request. This PR is the trigger for everything that follows. No PR, no review. Before anything touches AWS, the workflow authenticates using OpenID Connect. It assumes a scoped IAM role instead of storing a static AWS key in GitHub. That role is what's allowed to read AWS Secrets Manager, which is where credentials for the rest of the system actually live. No long-lived secrets sitting in GitHub at all. That's what kicks off the GitHub Actions workflow itself. It's the thing that actually starts the durable execution downstream. The workflow hands off to Temporal. And this is the part doing the heavy lifting for reliability. Temporal's own service tracks task queues, timers, retry state, and workflow history. If a step fails, Temporal retries it. If the whole thing needs to survive a restart mid-run, Temporal remembers exactly where it left off. This is what makes the pipeline durable and not just scripted. Temporal doesn't run the actual agent code itself. It dispatches work to a worker. In production, that worker runs as a container on EKS. That's the compute layer where the real logic lives. Inside that worker is LangGraph. This is the orchestration brain. It reads what changed in the PR and decides which agents actually need to run. Not every PR needs all four. Remember that this LangGraph needs to be wrapped inside a temporal activity. First agent, the Terraform agent. It reads the actual Terraform plan, what resources are being added, changed, or destroyed, and stays purely descriptive. It doesn't judge risk, it just reports facts. Second, the security agent. This is the one agent that owns every risk and severity call in the system, deliberately, so you get one consistent verdict instead of two agents disagreeing with each other. Third, the pipeline agent. It checks recent CI run history. Is the pipeline itself healthy going into this change? The fourth agent, the cost agent. This one does three things: real account spend, existing optimization recommendations, and the interesting part, a live price estimate for whatever this PR is about to deploy before it's ever created. Each agent reaches a real external tool through the Model Context Protocol (MCP). Terraform Agent talks to a real HashiCorp Terraform MCP server to get real plant data and not a mock. Security Agent runs a real sneak scan. Pipeline Agent calls GitHub's own MCP server directly. Cost Agent calls AWS's real billing and pricing APIs. Every one of these is a live tool call. Nothing here is simulated. Once all four agents finish, their findings converge on Claude. So this is the synthesis step. Claude reads every agent's raw output and writes the actual review, root cause, risk level, concrete recommendations. Last step, that review gets posted back directly from the worker straight to the pull request as a real comment. Notice it doesn't loop back through the GitHub Actions runner to do this. The worker talks to GitHub directly. So end to end, a PR triggers a durable temporal workflow which runs an orchestrated fan out of real tool backed agents on EKS, and Claude turns their findings into a review that lands back on the PR automatically, reliably, without a human babysitting any of it. The only task the reviewer needs to do at the end is review the PR and either approve the merge or reject it. That is where the human in the loop comes into the picture. If I had to boil this down to two ideas, temporal gives you durable execution and retries. Nothing silently fails and disappears. And LangGraph gives you orchestration. The system decides what work needs to happen and not a human. Together, that's what makes this a system you can actually trust to run unattended. Let me walk you through the code base. One thing I want to be upfront about right now, nothing here is deployed to AWS. No EKS, no Lambda, no DynamoDB, nothing. So everything you are about to watch is running on my laptop and including the temporal. The only thing that's real and external is the self-hosted GitHub Actions runner, which is registered against my actual repo and sitting there right now. It is listening for jobs on the same machine. All the actual intelligence lives in one folder, the agents. So there are 6 files: Terraform Agent, the security agent, the pipeline agent, and the cost agent. So these are the 4 agents. Summary agent.py. So this is the one that posts the final review back to the PR. And there's one more, llmutils.py. This is a small shared helper that helps both temporal and security agents, which use to hand their raw tool output to Claude for a real summary. So instead of just dumping a wall of text. Then we have this infra Terraform folder. So this is the sample infrastructure the whole demo points at. 4 files, a provider config, an S3 bucket that is deliberately misconfigured, public access disabled, an IAM policy that's deliberately over permissive, and an EC2 instance. So cost agent's pricing estimate has something real to price out. Now moving on to the temporal worker Python file. This is the one long running process in the whole system. It's what actually hosts every agent as a temporal activity. It registers the LangGraph pipeline with temporal and then just sits there waiting for work. CI workflow.py. So this defines what temporal is actually running. So the durable workflow wrapper around the LangGraph pipeline. We have this trigger workflow Python file. So this one only runs once per PR as a step inside the GitHub Actions job. Its whole job is small: read the real PR data, start the temporal workflow, and wait for the result. So as you can see, we have a task queue in here which is used by the temporal workflow, wherein the activities keeps on running one after the other. Graph.py, and this is the actual brain, the LangGraph definition itself, the orchestrator, which is the routing logic that decides which agents fire, the 4 agent nodes and the synthesis step. So every other file exists to run this one durably. As you can see, using this graph method, builder method, we can add several agents in here, which will help the LangGraph orchestrator to decide which agent to run when. And this file .env.example is the whole configuration surface. Anthropic API key for Claude, GitHub token and GitHub repo for the 2 agents that talk to GitHub, Sneak token that is used by the security agent to talk to the Sneak CLI. Then we have this TFE token, TFE org and TFE workspace, which is used by the HashiCorp Terraform MCP. And then we have this temporal address, temporal namespace and temporal API key, which is used by the temporal workflow. Before I do anything, look at both the windows. On the left, GitHub, no open pull request. On the right, temporal, zero workflows, nothing running. This is a true cold start. Everything you are about to see happens live from nothing. I am pushing a branch now. Two small, real changes. A job timeout safety net on the review workflows itself, and a cost attribution tag on the demo app server. And here's the PR. Add CI job timeout and environment tag to app server. Number 6. Watch the GitHub Actions site. Within seconds, the job starts. Review. No GitHub hosted cloud VM did that. That's my own self-hosted runner sitting on my laptop, picking up a real webhook from a real PR. The job checks out the code, installs dependencies, and runs one script, trigger workflow.py. Its only job is to start a temporal workflow and get out of the way. And there it is on the temporal side, the real input to the workflow, the PR title, the changed files, empty results waiting to be filled in. And below it, a live timeline. This is LangGraph's fan out happening in real time. Orchestrators already done. Security and pipeline agents finished fast. Terraform and cost are still running. You can see them as separate parallel bars, each one an independent temporal activity. And the job's done. Start to finish. Look at what temporal actually captured. Cost agents real AWS spend broken down by service. And this part I want to call out, a pre-deployment price estimate. Before this EC2 instance is ever created, the system already knows it will cost about 759 a month and correctly figured out the IAM policy and the S3 settings cost nothing at all. Nobody told it that, it worked that out itself, live against AWS real pricing API. This is Temporal's own event history. Every checkpoint, every node, every retry policy tracked automatically. This is the durability I keep talking about, made visible. And now back on the PR itself. The reviews already posted. Risk classification critical. And on the right, you can see the exact moment it happened. Real recommendations specific to this exact change. Block public access, encrypt the EC2 volume. The last one wasn't something I asked for by name. Claude found it on its own, looking at a resource it had never seen in this project before. And if you want to check its work, it's all here. This collapsible section holds every agent's raw output. Not just the summary, the actual cost explorer numbers, the actual pricing math, unedited. And that's the whole loop closed. The check passed, no conflicts, ready to merge. And a human still makes that call right here on GitHub, the normal way. The AI didn't merge anything. It just made sure whoever does has everything they need before they decide. So that was our multi-agent DevSecOps system. We started with a simple problem: how to make our CI/CD pipeline smarter and more secure using AI. Instead of building one massive agent that tries to understand everything, we split the problem into several specialized agents. Then we used LangGraph to orchestrate these agents, deciding what needs to run, running independent checks in parallel, and bringing the results together. And we used Temporal for completely different: durability. Because in a real production system, it's not necessary for the agent to work when everything is healthy. Workers crash, APIs timeout, tasks fail, network disappear. And that's where durable execution is extremely important. If you enjoyed this kind of AI, system design, and DevSecOps content, please keep following the Techie Chef. I'll see you in the next one.